Com check, com check. Can you hear me?
We can hear you.
Okay, great. Okay, I guess I am going to start with an announcement since I see my announcement tab up there. A student emailed me or messaged me in Canvas a couple nights ago, said I have no clue what's happening in the class. And I said, okay, let's start from scratch, and gave the student some simple assignments. And what I'm actually building up to is a tutorial that starts from ground zero and presents the object-oriented method in a different way than I presented it in class. So I think what would be the right thing to do is to create a new module, I'll call it tutorial, and present these assignments and solutions in these. Does this sound like a good idea? I can't imagine it will harm anybody. And then yeah, so I think that I think that there's more than one student who says, "Oh, I have no idea." And if you're one of those students, let me know. And so yeah, I'll do this. It's basically what we're building is a tutorial that starts from ground zero, and we'll go up and build what is hopefully an interesting piece of code with some interesting animation effects. That's the long-term goal. And long-term, I'm thinking, I think we can get it done by the end of next week if all goes well. Okay. But that way, everyone gets to benefit from this thing. I started out last week, I did the non-interactive flood map. And if you remember the way that went, I said model view controller. I built a model of the terrain. The model of the terrain was a post map. A post map is nothing more than if you take real terrain and imagine take real terrain and then, carve it into imaginary squares and take the average elevation in each square and then model that as a flat field with posts where each post height matches the average elevation of that square. So you've got a 2x2 grid of posts of different heights. And this is done in animations all the time. And then what they do is they throw a skin over it and the skin drapes over the posts and it looks like you got cool animation. So that's the way we're doing it here. So what I have is a 2D array of posts, which are nothing more than numbers representing the height of the terrain or the average elevation of the terrain in that square. And I artificially restricted it to integer values between 0 and 10. And then I created an array of rectangles on the screen. So model view controller, the model is the post, the view is the rectangles. And there's a one-to-one correspondence. So if I have a 30 by 50 array of posts, I need a 30 by 50 array of rectangles. And then I just color the rectangles based on the post value, based on the height of the terrain. Then lastly, I added water to it, where if anybody was lower than the current water level, I would paint them blue. Now we're going to add some simple interaction where we have buttons that can allow us to change the water level. So if I run this thing, as you can see, I have buttons and I start out with no water. So everybody at sea level is still blue. 3 meters of water, 5 meters of water, 8 meters of water. Those black squares are a flaw in my programming, by the way. They rounded up to 10 and I didn't put that in my case statement. Back to 5, back to 3, back to 0. So we can play around with how flooded this land looks. Now it's lousy looking land because it's random, right? I made it random stuff. If you really wanted to do this, I would say use file input and build a file that represents some real elevation of some real piece of terrain you were interested in. Okay, so we know how the post map looks. It's just a bunch of 2D array of numbers, 0 through 10. We know basically what the map pane looks like in terms of the rectangles. It's just a 2D array of rectangles. what do you expect to see for the buttons? You know, based on what I keep telling you, you know, you build the nodes, you position the nodes, you add the nodes to the pane, right? So in that sequence, what are we adding? Before we had no buttons, right? So I'm going to add the buttons. Then what do I do?
Probably like the set on click
Yeah,
method or whatever.
exactly, yeah, whatever that is. And by the way, you don't need to remember what that is. And the reason you never need to remember what these things are is that's what Oracle help pages are for. That's what documentation is for. That's what tutorials are for. All you have to remember is you can tie an action to the button. So I'm going to build a button, position the button, tie an action to the button. What action do I want to tie to the button? For example, for the 5 meters, what action should I tie to the button? Oh, I should probably check to see if all the rectangles are below, you know, which ones are below water and paint them blue. So if we look at the actual code, the post map, which is the model, I didn't have to change at all. And the map GUI, which is the top level one that produces the stage, produces the scene, produces the pane, I didn't have to change at all. The only thing I needed to change was the map pane. And remember, what I tend to do is I keep my top level stuff really clean, this top level GUI file really clean. All the work goes into the pane. And you'll see I actually extend that a little more in the next example that we're going to look at, which won't happen until Monday, I think. That Pirates game that I have. I actually have a game with a game controller, and then I have inside the pane that I build, it actually builds a game controller. So I get a little more separation between the view and the model. You do need a controller though to interact with the model and the view. All right, so let's look at the map pane. And again, I recommend that you don't do all your work in the top level methods. Now, in a normal file that didn't have any GUI applications, the top level method was main. And I said, don't do all your work inside of main. Make methods and then refer to those methods. And in a GUI application, the top level is start. And I say, don't do all your work in start. In fact, look how short start is inside my map GUI. It's that big. And the only line that actually does anything is map pane pane equals new map pane. Right, so I'm pushing all that detail out. Push the details down to the lowest level you can. So inside the map pane, what's the top level method? It's the constructor. So for any object, the top level method is the constructor. And inside this constructor, I could put all the details about how to build all the rectangles and how to position them and how to build the buttons. And man, what an ugly method that would be. Instead, make a bunch of methods that do one little thing. So I've got one method that makes the post map, it makes the random map right here. See, my post map equals new post map. And then I say, hey map, right? Make a random version of yourself. Where should I find this method, make random map? What file should that be in? Let's see, it's map.makeRandomMap. So what object is being affected here?
The map object.
The map object, right. And the map object is a post map. And sure enough, if I look in post map, I have make random map. So if you wanted to see the details of how a random map was made, you'd know to go to that post map class. Since it says, I'm in the wrong one again. There we go. Since it says map.makeRandomMap, that means I'm asking the map to make a random map. The map is of the class postmap, so I have to go look in the postmap.java file if I wanted to know those details. Then I have create rectangles in pane. Now, since there's no object reference in front of it, it must be inside this class. And sure enough, there it is, create rectangles in pane. Notice I made that as a private class. That's because I assumed nobody else would be doing that. I'm sorry, a private method. I assume nobody else would be doing that. Yeah, usually you should make your methods public. Sometimes it's okay to make them private. And then I color the rectangles. And then I make buttons for the water level. And then I color the water level. Exactly what I said I was going to do. Make the map, make the rectangles, color the rectangles based on the map, make the buttons, color the water level. And if we go back to make the rectangles in a pane, let's see, let's go back. I'm sorry, I'm scrolling up and down on you there. Here, I start out here with private rectangle with the double bracket, rectangle map. What does that tell you? Rectangle map, this guy here, rectangle map. What is it? Is it a rectangle? Is it an array of rectangles? What is it?
That's an array of rectangles.
Right, and it's a 2D array of rectangles. That's why I have square bracket, right? So I have rows and columns. So it's a 2D array of rectangles. Now, in this line here, when I say private rectangle map, we know rectangle map is going to be a 2D array of rectangles. Have I actually created the array at this point on line 33? No. How do you know? Why are you right? What do you need to see? No new keyword, exactly. So remember, an array is an object, right? How do you know when you get a new object? The new keyword. So I didn't actually create that object yet. What do I have? I have a handle, right? A place to store the handle. So when I actually create the object later, I know how to go grab that object. So when I create the array later, then I know how to go grab that array. So then down here, I say rectangle map equals new rectangle n by n. Now have I created the array?
Yeah, since you used new.
Yeah, I've got the new keyword. I've got the new, well, I did it as a variable. It is private. Yeah, so that's a good point. Lillian says it needs to be private. It is, because remember I declared it up here, private. And then I actually created the rectangle down here. So it is private. And this is common. Declare your attributes without assigning them any values. Later on, if somebody needs to give them a value, they'll give them a value. So now I've actually created an array. And in this case, I think it's like 30 by 40. So I've created an array of a 2D array of rectangles. What does that 2D array contain at this point? Does it contain any rectangles at all? No. Why? How do you get a new rectangle? New rectangle, right? We don't have that. Here's what we have. We have a 2D array. We have kind of like a garage where we're going to put rectangles someday, but we haven't put any rectangles in the garage. There's two ways to think of it. One is, if you want to think of the rectangles as being physically in the array, you've got the spaces for the rectangles, but you haven't put any rectangles in yet. That's one way to think of it. Another one is to think of remember an object name is just a handle. What we've got here is a bunch of handles. but we haven't created the arrays for the handles to go grab yet, or to, if you would like to think in terms of pointers for the handles to point to. So what do I have to do? I've created my rectangle map, which is a place to store rectangles. Now I have to create all the rectangles. So here I go through my doubly nested loop. It's a 2D array, so you're going to have a nested loop. And I say rectangle map ij equals new rectangle. Does that line create a rectangle? An actual rectangle that you're going to see on the screen. I should say an actual rectangle that eventually we'll see on the screen.
Yes, it does.
It really does, because it says new rectangle. And where's the rectangle positioned? The X location is at 50 plus R size times I. The Y is 30 plus R size times J. And how big is it? It's R size by R size. So the horizontal length is R size, or the horizontal dimension is R size. The vertical dimension is R size. I'm making squares. What's that 50 plus R size times I? I wanted to make it, try to make your code as generalized as possible. I wanted to make it where they would all lay out one after the other, and I wanted them to be offset a little bit. So that's what that R size times I is, and R size times J. It's to lay them out in the right row and column. And then the 50 and the 30 are just offset X, offset Y. Then I take each rectangle, I color the edge black, I color the insides white, and then I add them to the map. And notice I have to add them as an individual rectangle. Rectangle map ij refers to one rectangle. Now a rectangle being a graphical object. So notice these levels we have to think through. It's a little bit confusing at first until you do it a few times. And that's why, again, I always encourage you guys to take this code, which I've supplied to you, play with it, try to make your own stuff. Start with simple things and try to make your own things. And you'll find that if you spend, a half an hour trying to do something like that now, your April, when you're working on your project, will go much better because you're working on the specific skills. So you'll know how to, you won't be, stumped by them in April. Notice, by the way, when I add the children, normally what were we doing? Pane.addChildren.add, right? Remember that? Pane.addChildren. Why is that? Because we were building the pane in that top level GUI class, but here it just says get children. Why? I'm already in the pane. Remember, if you're using a method without anything in front of it, you're using a method name, it's already in that class. So this is just get children. It's get children to itself. That's why rectangle map should be an attribute, so that all the methods have access to it. Okay, so that created the rectangles. Then once you create them, the rest of this is pretty straightforward. I color the rectangles. And again, we saw this the other day. All I do is I compare each rectangle against its corresponding ij location in the post map. And based on the height, I give it a color. That's it. And then I color the rectangles based on the water level. And all I do there is I've already colored them based on their height. Now I just check against the water level. And if they're at or below the water level, I recolor them blue. Otherwise, I leave them alone. Now I want to create the buttons. And as we said, we're going to create a button. We're going to set its XY location, and we're going to do the set on action. And then we're going to add it to the pane. And so that's what happens in here, make all buttons. And notice making all these things it's hard to get around not having a long, messy method here. GUI stuff is just intrinsically messy. So first I build the label, and I set it at 250 pixels offset from the on the x-axis, and then I put it 40 pixels below all the rectangles on the y-axis. That's what m times r size is. I again try to make your code generic. If I fixed the y location of the label, and then I added more rows of rectangles, the rectangles would cover up my label or obscure it. So I'm always making sure that I'm 40 pixels below the last row of rectangles. I should do the same with the X layout. I have it fixed, and if I change the window size, I should probably have that adjusted also. But oh well. And then I add it to the pane. And then I'm just going to go through one button because all the buttons are exactly the same. I create a new button, BT0. Again, BT to remind myself it's a button. 0, that's kind of its job, is to do the 0 water level. Could have called it BT 0 water level. So it's always BT for button and then name what it is. I lay it out again, fixed on the x-axis at 100. Now I put it 70 pixels below the row of rectangles. Yes, I laid this out beforehand. Yes, I played around with 40 pixels for the label and 70 pixels for the buttons to see what looked good. It's an iterative process. And then the important part, finally, we have a button that's going to do something. We're going to do BT0 set on action, where we're tying the behavior to the button. So again, E for event, arrow, that's actually a negative sign greater than sign, E arrow, and then you can put in anything you want to happen. And I want two things to happen. So since I want two things to happen, I put them in curly brackets. Never hurts to put them in curly brackets. What do I want the BT0 to do? I want it to color the map as if the water level was at 0. So I call in color rectangles and color water level. And again, notice the value of object-oriented design where I keep saying, make methods that do small little things. You're going to almost always reuse those methods. So I don't have to do anything new to color this thing. All I have to do is call my pre-existing methods. And then I add that button to the pane. The only thing that's different here, once I did this, I cut and pasted and just changed a few things, right? It was BT0, and then for BT3, 0 became 3. And in my color water level, where I put a 0 in here, I put a 3 in there. And then I add it to the pane. So straightforward, hopefully straightforward stuff. Let's stop here. Are there questions? Yeah, there's questions. You may not be asking them. I'm sure there's questions. So what are the questions? That's a better question. Okay, top level view here. Number 1, make your methods small. So they're doing one thing at a time. And if you can figure out a way to build them up that way, where you only have to build one method, check it out, build another method, check it out. That's a good way to do your design. Don't code a lot of stuff, compile and hope it runs. Just a few lines of code, compile and run. Once you build up these methods, you can reuse them. You build more complicated behavior by just calling method after method after method. For the GUI stuff, it's always the same process. Build all your nodes, position them. If you need them to do something, tie an action to them. Add the nodes to the pane, add the pane to the scene, add the scene to the stage. Can you do all that in this top level GUI file? Could you do it all in there? Yes. Is it a good idea? I think not. I think since all the dirty work is in the pane, and by the way, notice we wanted the pane to have some attributes. So when we built those different methods inside the pane, we would have access to those attributes. So since all the work is going on in the pane, I say, make your own specialized pane. Map pane extends, where is it at? Map pane extends pane. Okay. It's not a bad model for your projects. Map GUI, map pane extends pane. And like I said, I'll show you an example where I even extend that a little more, pushing the dirt further down. Push all your dirty work as far down as you can. If you do that and you have good segregation of responsibilities and actions, then it turns out you can modify one class without having to touch the other classes, or maybe just touching one of the ones next door. Once you get into this, again, don't do all the work in one great big long method. Break up what you want to do. It's okay to think in terms of, well, you know, here's how I do it. Well, let me see. I want to do this. First, I have to do this. Then I have to do that. Then I have to do that. Each one of those is a method. Each time you say, then I have to, then I have to, then I have to. Each one of those can be a method. It's a not a, you know, it's not a science. It's an art, right? You learn it over time, and you know, heaven knows it never becomes you know, perfect or super easy in terms of, you know, if you're pushing your boundaries of your skill level, then of course it's not going to be straightforward all the time. Okay, let's get into animations. This is some basic interaction, but there's no animation. The Java word for animation is transition. So we're going to look at 3 different transitions. This discussion will carry over into Monday, I'm sure. So if we look at transitions, the basic transitions that the author talks about and that I present in the class are the fade transition and the path transition and the timeline transition. And of those 3, most of you won't use a fade transition in your projects. Most of you won't use a path transition in your projects. If you're going to use one, you're going to use timeline. Now, some of you may not use anything. This is only if you have literal animations on the screen, but there are people who don't need that. There are people who are doing an analytical simulations that are a bunch of number crunching. And all they need on their GUI is to allow the experimenter to set up the parameters of the experiment and then click the button that says go, and that button is tied on, it's set on action, is tied to run the simulation. But often when you're running simulations, you know, you don't see them on the screen. You know, usually you're running thousands of repetitions of it. Who wants to watch that? Okay, so we're going to look at fade transition, which most of you won't use, but it's a great introduction. And path transition, which is the next step introduction, and then timeline. Timeline is exactly, I always think of it as a movie. It's a movie where you have, movies go frame by frame by frame. And that's what's happening. You have basically literally they call it a keyframe. You're basically doing frame by frame by frame. And what you're setting up is in each frame, you can declare an action to be performed. And when that action gets performed over and over and over and over as the timeline goes through, then you get animations. Okay, so let's look at fade. It does what you would expect it to do. It fades. Now, some of this you can already, before we look at the code, you can already guess some of what you're going to see. You know, what are the basic elements that you know you're going to see when we go look at the code? Is there a stage?
Yeah.
Yeah, we better see a stage. And what's inside the stage?
Scene,
Probably a scene. We better see a scene. And what's inside the scene?
panes,
A pane. And then inside the pane, it looks like we only have one node. What is that one node? It's a,
just a colored
yeah, it's
oval or
yeah, it's an oval or circle or something. It looks like it's not a circle, right? And they painted it red. And then the thing that's really new here is the fade transition. Now, again, everything is an object. So the fade transition is an object. They're going to build a fade transition object. And then they have to set the parameters of the fade transition. What is it that's fading? So they're going to take their ellipse and tie it to the fade transition. And then we'll see they do other things. Notice it fades in and out. That's a setting. You could have it fade away and just go away. It fades in and out repeatedly. In fact, it does not appear to ever stop. That's a setting. So does it fade away or does it fade forward and back, forward and back, forward and back is one setting? How many times should it do that? Apparently forever. And then things that are not as obvious, we'll look at. So here's what the fade transition looks like. There we go. All right, so things that we expected to see are here. Application, you have to have that because it's a GUI. Scene, stage, pane, ellipse, color, those are not surprising things. The parts that are related to the fade transition, well, the fade transition is related to the fade transition, clearly. And then this timeline and duration. And I believe it's, oh, I get these messed up. I think duration is how long do you want the fade to last, and then timeline is how many times do you want to go through this. So when we see what's happening here, we build a pane. This is the author's work, by the way. So, and then build an ellipse. And they do some cute stuff with the ellipse. They, you know, first they set it, set the color red, set the outside black, but then they actually bind it to the pane itself so that when I'm, pane width property, so they bind it to the pane itself so that you see when I'm changing the size of the window, the ellipse was changing. That's how they do it. They bound the width and height property of the ellipse to the width and height of the pane. Most of you don't need to do that. But it's good to know it's there, right? How would you ever do it if you needed to? You'd go look at the Oracle help pages. You'd go look at examples. And then they add the pane, and they add the ellipse to the pane. Now the fade transition. Oh, they build a new fade transition object. And let's put that on one line so it's a little easier to read. How do we know it's a new fade transition object? The new keyword. And the constructor for this, it turns out, duration millis, so it's 3,000 milliseconds, 3 seconds long. And what's fading? The ellipse. So again, most of you aren't going to use the fade transition, but it's a great introduction to animation because you're having to do similar things in different forms of animations. You have to talk about who's affected. Who's being faded? Oh, it's the ellipse. How long does it last? 3 seconds. How often do I do it? Forever. Timeline indefinite, forever. Notice indefinite's all caps, right? That's basically their constant value for infinity. Auto reverse true. Oh, that's why it fades back and forth. The one that's not so obvious is the from value and the to value. The from value 1.0, it's fully visible. The to value is 0.1, so it's 1/10 visible or 90% transparent. By the way, someone's doing a treasure hunt game, and I think in this class, and I keep thinking, oh, how could you give good clues to the player for the treasure hunt rather than just random walk? Maybe have the ground over the treasure fade back and forth or fade out and fade back to give them a clue or something. So anyway, that's the fade transition. Oops. Okay. Now, so if I go back here and look at this, all of those things show up. Now they put a surprise in here. Ellipse.set on mouse pressed E arrow ft.pause. What do you think that does? What do you think's going on there?
That'll probably stop it from fading in and out.
Right, it pauses the transition. All these transitions, the way you make them go is with play, with the play method. They come with that. You don't have to do anything to it. They come with that. And so if you want to stop it in animation, it's pause. Some of you guys are saying in your user stories, oh, I want the user to be able to pause the game. You can have a button down there that just literally pauses the game. And then, you know, so they go answer the door or whatever. And then when they come back, they can click it again and it'll do play. So when I do set on mouse press, now where do I have to press my mouse though? Can it be anywhere in the stage or does it have to be in a specific place? Who is that action tied to? Anything in specific? Anything specifically?
It's tied to the ellipse. It probably
It's
just
tied
wants
to
to
the
click
ellipse.
the ellipse.
It's tied to the ellipse, right? So on the ellipse, set on mouse pressed, pause, on mouse released, play. Now remember, with a button, you do set on action, which is clicking on the button. But remember, all of these GUI objects, you can set action, you can tie actions to. And usually it's about clicking on them. But you can do if they got dragged, if you do on drag, on drop, on mouse over, on mouse exit, you know, you can do all kinds of things. So if I'm inside here and I click my mouse, so here I am clicking my mouse, notice how it stopped. And I release the mouse and it goes back. If I'm out here, not on the ellipse, and I'm holding my mouse key down, it doesn't stop because that action was tied specifically to the ellipse. If I click on while I'm on and I try to trick it, I'm going to try to freeze it. I'm going to let go. That's too smart for me. Okay. Okay, but the idea is it only works for the ellipse. Why? Because it was tied to the ellipse. How do you know that? It says ellipse dot set on mouse press. All these GUI objects, remember, come with, I don't know, a couple hundred methods that you can overwrite, that you can set. Okay, so that's the fade. Some key things to think about here is auto reverse, setting the cycle count, setting the duration. Now let's go to path transition. Oh man, me and my... As much as we type these days, you'd think we'd all be good at it, and maybe you guys are. Me, not so much. All right, notice, by the way, since nothing changed when I changed the window, did they set the positions as an absolute value or did they bind it to the window properties or the pane properties? You know what I'm asking you? That circle and that rectangle are in a position, right? And when I change the size of the window, right? So what does that tell you about how they're going to position these things? Did they fix them in one place or did they bind the position to the window so that when I change the window, they move around and always stay in the center or something like that?
Well, it looks like it's just staying in one place.
Right, they must have fixed it. So we're going to expect that, right? We're going to expect that they got fixed. Now, in order to do the path transition, take wild guess. What do we need? What do you expect to see when you get in the code? I'm going to tick off the easy stuff. I expect to see a stage, a scene, and a pane, and then nodes inside the pane. What nodes do you think we're going to see? What nodes are you looking at right now? What shapes are you looking at?
And there will be nodes for a circle and a rectangle.
It's got to be a circle and a rectangle, right? And then there's going to be a path transition. And the way the path transition works is you say, here's the path and here's the thing on the path. So I fully expect to see create a circle and position it, create a rectangle, create a path transition where the circle is the path and the rectangle is the thing on the path. And then I'm going to see some of the same stuff I saw before. Duration. How many times should I do it? Does it auto reverse? Does it go back and forth? Now, what do you think for does it auto reverse? Yes or no?
Yes, it's like
It looks
going
like
one
it's
way
going
and
back and forth,
stopping.
right? Yeah, it looks like it's going back and forth. How about duration? I'm sorry. How many times? Repetitions. That's the timeline. How many times do you think this goes? Yeah, it looks like it goes forever, right? Right. And then the rest is the duration. And if you get your stopwatch out, 1, 2, 3, 4, I'm going to go with 4 seconds. And I know it's 4 seconds because I saw it an hour ago. So that's what we're going to see. Now, how did they get that rectangle to always point towards the center? That's the cute trick. And I would have spent a long time doing a bunch of geometry only to find out that I didn't have to. So when I look in here, sure enough, they create a pane, they create a rectangle, they color it orange, they create a circle, they color it white, and then they add the circle and the rectangle to the pane. And then just as we expected, they build a path transition, they call it PT, and they set its duration to be 4 seconds. The path is the circle, the thing on the path, the node is the rectangle. And then I'm going to get back to that set orientation. Then they set the cycle count, to do this forever, and auto reverse is true. Those are all things we expected. And then the cute trick here is this orientation. Who knew? Right? Who knew they could do that? So there's no need for you to break out your trig book, or remember what tangents to circles are. It will automatically rotate that rectangle as it goes around. And then all transitions have to start with play, so it's PT play. And again, this is better introduction towards the timelines again. And down here, they do the same trick where you can pause it. So what? Circle set on mouse press. So a circle set on mouse release. So pt.pause. PT, remember, is the name of the path transition. Path transition PT equals new path transition on line 32. So whenever they refer to PT, it's the path transition. Notice, by the way, in object-oriented programming, and we say, oh, you need to think of your code as if it was an actual object. And we start out with really concrete things like a stapler, right? I can start out with stapler and sheep and dog, right? These are very concrete objects. It's kind of hard to think of an animation as a physical object, right? But it is an object and still in software. So the path transition, which is not really relates to a physical thing, is an object still. Now, when I go back here and I do mouse press, mouse release, notice it's tied to the circle. So if I'm inside the circle, I can pause it. If I'm outside the circle, no pause. I wonder if I'm in the, I'm going to wait till that rectangle comes around. In the rectangle, no, okay. But if I'm inside the circle and I'm on the rectangle, look at that. Did you see what happened? We got it now. There, the rectangle obscures the circle. So when I clicked, it was clicking on the rectangle, not the circle. See, what a weird thing. If you were designing that code, would you think of that? I would not have. And then I would have a user complaining that my code didn't work. All right, so that's path transition. I'm going to introduce the timeline, but we're going to go over it on Monday again. For timeline, we do bounce ball. And bounce ball is the hello world of the graphics community. And It's called bounce ball because it bounces. So whenever it hits an edge, it'll bounce. Where'd you go, bounce ball? Yeah, there it is. I just found a flaw in the code. That's great. Okay, so how do they do bounce ball? They do two things here, bounce ball and ball pane. And the top level GUI is just getting the, building the scene, building the stage, right? And then they take, since the dirty work is done in the pane itself, they build a pane called ball pane. Now, if I was going to do this, I would actually have a class just for the ball, and then a class for the ball pane where it builds a ball object. And then I would have a class at the top level GUI. And the only reason I would do that is because if I wanted to make this more complicated later on, keeping the ball separate from the pane is a helpful thing, right? It's its own object. So, public final double radius, they're setting a constant there. Should never make it public, and probably shouldn't have constants. Then they have a bunch of attributes in the pane. You know, you can argue as to whether you need these things. This dx and dy, that's the speed. It goes 1 pixel per tick, right? So every frame of the movie, this thing is moving 1 pixel. Originally 1 pixel in the x direction, 1 pixel in the y direction. Technically, that's not tied to pixel, but they do use a one-to-one correspondence here. In your hare and hound programs, your hare and hound, the limits on the field of play are like 2,500 high and 2,000 across, which is bigger than a screen. So you actually need to scale that. You know, if you did a 5-to-1, let's say you did a 5-to-1 scaling where every 5 units, every 5 meters in the game was 1 pixel on the screen, then be aware of scaling that. So if your hare is at 1,500 meters of height, that would be 300 pixels high. But here it's a 1-to-1. And they put an animation in here. All right, we're going to just fly through this, but on Monday, we're going to come back to it. They build a ball, they build a circle, they color it green, they add the circle to the pane. And then there's the animation for this. It's got a lot of the same stuff as you would expect. It's got the duration. Here they do it 50 milliseconds. So every 50, you know, think of a frame of a movie. It's every 50 milliseconds. So you're getting 20 frames per second out of your movie. You could probably make that a little faster, right, for smoother work. And then they tie an action to the timeline. So E, move ball. In other words, every frame run this method. For every frame, run this method called move ball. And how long do you do it for? Forever. Oh, okay, that's all you need, and then play. It's pretty straightforward. That's really all you need for an animation. So all you guys that are doing, you know, the maze games and the platformer games and whatever, you know, you can do it with this much, where the trick is move ball. What can you put there instead of move ball? Any method you like. So how does move ball work? We don't care about that necessarily. You can look at the behavior of it. It just keeps going in a line, and when it hits an edge, it'll bounce. That's all it does. It's bounce ball. So all they do is they flip flop the X and Y speeds. You know, you can look at that. The critical part here is the animation. And now we're going to move on Monday to bounce ball control, where we can speed the ball up and slow it down. Okay, so that's it for today. Like I said, we'll have to pick this up on Monday and finish this material on Monday. On Friday, I want to keep that pure for the project. So Friday, we're going to talk about the peer review stuff, and I'll entertain questions on P3. Questions about this so far? You won't understand it until you play with it, you know. Whoops, 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 whoops. It really is. It's not something you can just look at and say, oh, I got it. You really need to run these files, and then I highly recommend that you modify these files and try to run them or build your own bounce ball from scratch. All right, guys, I'm really late. Got to let you go. See you on Friday.